Electric network elements, thermal power production technologies. In this video, we'll talk about thermal power production technologies. At the end of this module, you will be able to describe several thermal power production technologies and their characteristics. A thermal power station is a power station in which heat energy is converted into mechanical power that is used for electric power generation. The conversion process from thermal energy to mechanical energy can use a steam or a gas turbine or an internal combustion engine. This mechanical energy is then used to operate a generator and produce electric power. All thermal power plants use the energy extracted from expanding gases, either steam or combustion gases. As the name suggests, a gas-fired thermal power plant uses gaseous fuel to produce mechanical energy. The most common fuel used in gas-fired stations is natural gas. However, a number of other gases can also be used. For example, biogas or liquefied petrol gas, also known as LPG. In order to create mechanical energy from the thermal energy of combusting gases, a gas turbine is used. The gas turbine has a similar working principle of an aircraft jet engine, but instead of being connected to propellers to produce thrust, they are used to rotate generators to produce electric power. The combustible gas is added to the turbine, along with a stream of air which then combusts and expands through the gas turbine, causing the blades inside the turbine to turn and produce mechanical power. There are two types of natural gas power plants: simple cycle gas plants and combined cycle gas plants. The former consists just of a gas turbine generator unit, and the latter adds another steam-powered turbine to the mix. The simple cycle plants are less efficient, reaching to about 35% peak thermal efficiency, but they are also easier to build. The second type of gas-fired power plant utilizes what is known as a combined cycle. Combined cycle power plants are more efficient because, in addition to the simple cycle process, they make use of the waste heat in the exhaust gases from the gas turbine. These exhaust gases are used to boil water into steam, which is then used to spin a secondary turbine and generate more electricity. The thermal efficiency of this type of plant can go up to 68%, compared to that of about 35% of the simple cycle gas power plants. The cost to build a combined cycle power plant, however, is generally higher, since it is more complex. In a coal-fired power plant, a steam-driven turbine is used to convert heat energy into mechanical and then to electrical power. In essence, the working principle of a coal-fired power plant is the same as the secondary part of the combined cycle gas power plant. Water is heated in the boiler, where the previously pulverized coal is combusted with air. In the boiler, the water turns into steam and is then directed into a steam turbine, which, in turn, drives the electrical generator. After the steam passes through the steam turbine, it is then condensed in a condenser and recycled to where it will then be heated again. The thermal efficiency of coal-fired plants is up to 35 to 38%. The conversion to electrical energy in nuclear power plants also takes place indirectly, utilizing steam power. There are two major types of nuclear power reactors: boiling water reactor and pressurized water reactor. In boiling water reactors, the fissile nuclear material that produces heat directly heats up the water that is used to make steam and produce mechanical power. The disadvantage of this is that any fuel leak might make the circulating water radioactive, and that radioactivity might reach the turbine and the rest of the loop. These types of reactors have a thermal efficiency of about 32%. In pressurized water reactors, the water which circulates over the reactor core does not flow into the steam turbine directly, but is contained in a pressurized primary loop. The primary loop water produces steam in the secondary loop, which is used to generate steam to drive the steam turbine and produce mechanical power. The advantage of this is that a possible radioactivity leak in the core is contained in the primary loop of the system, and the rest of the system will not encounter any extra radioactivity. These types of reactors have a slightly higher thermal efficiency because they are able to operate at a higher temperature. About 11% of the total electric power produced in the world comes from nuclear power reactors. To conclude, thermal power productions have the same principle, using turbines to make a rotating generator. The main difference is how the turbine works according to the primary energy source. Thanks for watching.